GATE 2021 Metallurgy. Question number 24. Water flows over a plate of finite length at x is equal to x1 from the leading edge. The velocity of the flow is Vx is equal to 0.5 times y into 0.5 times y cube. The thickness is delta in meters of boundary layer at x is equal to x1 is what is given is V infinity is the free stream velocity. Now to solve this problem, I am going to make certain assumptions. The first assumption I am going to make, I am going to assume the flow is steady. Steady flow. Steady flow means no variable changes with time. That is, change in variable with time is 0. It's a steady flow. Second assumption is the flow is incompressible. Incompressible flow. By incompressible flow, I mean the density is constant. Third assumption, the flow is two-dimensional. Two-dimensional flow. That is in x and y coordinates only. Fourth assumption, there are no gravity effect. Gravitational effects are neglected. And the fifth assumption is there is no edge effect. No edge effect. Sixth assumption, the boundary layer is thin in comparison with the length of the body, or the length of the body is much larger than the boundary layer thickness. Now, using these assumptions, I am going to proceed with this problem. So in the problem you can see there is a flow is taking place in x direction. V infinite represents the free stream velocity. Here delta represents the boundary layer thickness. At boundary layer thickness, the velocity of the fluid is almost equal to the free stream velocity, or V delta is 0.99 times the V infinity. Okay. Now, due to the shear stress, the velocity changes as we move away from the flat plate in y direction. Now, as per the Newton's law of viscosity, the shear stress is nothing but minus mu dvx by dy. Why minus? Because the shear stress reduces with increase in y. Now, moving ahead, applying the boundary conditions on the boundary layer. So at free end, as y approaches the boundary layer thickness, the shear stress approaches 0. Means at boundary layer, the shear stress is negligible. So using this boundary condition in this problem, so it will be nothing but minus mu is dynamic viscosity here, dvx by dy. Since the value of Vx is given to be value of Vx where Vx is nothing but 0.5y minus 0.5y. Okay. So solving this problem, therefore, if you differentiate Vx with respect to y, we will get dVx dy is nothing but 0.5 times differentiation of y with respect to dy is 1 minus 3 times 0.5 y square. Okay, and it is equal to 0. Now, upon simplification, we can write y square is nothing but 1 by 3, or y is 1 by root 3, and that is equal to 0.577. Okay. Hence, the thickness, that is lambda or delta, of boundary layer at x equal to x1 is nothing but 0.577, okay, at the x equal to x1. For more details, you can refer the video reference from the NPTEL. It is lecture 34, Fundamental of Fluid Mechanics for Chemical and Biomedical Engineers by Professor Raghavendra Gupta, Department of Chemical Engineering, IIT Guwahati.